This is problem 7-70 from section 7.1.4. While working on their homework on sequences, Davis was suddenly stumped. "This problem doesn't make sense," he exclaimed. Tess was working on her homework as well. "What's the problem?" she asked. "This problem is about a sequence, t of n equals 9n minus 2, but it is asking whether or not is it a function. How can a sequence be a function?" "Well, of course a sequence is a function," said Tess. Who is right? Should Davis be confused, or is Tess correct? What is the difference between a sequence and a function? Explain completely. Well, let's start with our oldest thing, which was a function. What is a function? A function is something that is a 1-to-1 ratio. So that means if I have one input, I get one output. Okay. So that means, let's think of some examples that are functions. So a function could be a line, going down here. If I plug in x equals 0, I only go to one spot on the graph. Something else that is a function is a parabola. If I plug in x equals 0, again, I only have one spot on my graph. Right about there is the spot. Yeah, that's a good one. Okay, so something else that is a function is something that looks like this. As long as I plug in one point and I only get out one point. Something that is not a function. Let's look at some of those. A sideways parabola. We talked about those. Sleeping parabola. If I plug in x equals, let's say about 4, so say that's like there, I go to 2 spots on the graph. It does not like going to 2 spots on the graph. Those are not functions. If we make our points larger again, you can see that. So here is one spot on the graph. What? It is not cooperating with me today. So if I go to one spot on the graph and I get 2 outputs, that is not a function. So this one is a no. A circle is also not a function. Okay, here's my circle. Very poor excuse for a circle, but up here and down here, I'm going, when x equals this thing, I'm getting 2 values. There's also something called the vertical line test. If you can pass a vertical line through it, and it touches, see if I can be really cool. Oh yeah. If it touches twice, see right there, touching twice, 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 that is not a function. If I go to my parabola, it's only touching once everywhere. Once everywhere, same thing on my line, once everywhere, okay? So that's called the vertical line test, if you hear that. So we know what a function is now, but is a sequence a function? Well, what is a sequence? A sequence is going to be kind of a pattern of numbers, but it's discrete. Okay, discrete, we talked about this, means you don't connect the points. So in my example above, I have points like this. I do not connect them. We've talked about this a while ago when we were doing the bouncy balls and dropping the balls from different levels. We said number of trials. We didn't have a half of a trial or a 3.25 trial number. We just had integers being our trial numbers. 1, 2, 3, 4. So that means my domain is limited with my sequence. I also don't ever have the 0th term provided for me in the sequence. It starts with 1. 1, 2, 3, and it goes so on like this. So I don't have 0 in my domain. So sequences are going to be discrete, which means they're points, and it has a limited domain. So does this fall under the function? Is it a function? Would it pass our vertical line test? If I plug in x equals 1, do I only get one output? Well, in the sequence that they gave us, t of n equals 9n minus 2. I know that's kind of like a line, except since it's a sequence, they're disconnected. So I could either make some points here. So when I plug in 1, I'm going to get out 7. So next is worth 1, I'm up at 7. Is there any way, if I plug in a 1, would I get a different number out? Unless you did your math wrong. You would not get another output for this one input, okay? So if I keep going, my graph is going to keep going like this, kind of in the red way up there. And I'm not going to connect my points because that's what a sequence is. So, is a sequence a function? Yes, sequence is a function. Sequences are functions. And that's because for every one input, or x value you plug in, right, input means x, you get one output. Only one. So it doesn't matter if the points are connected, the sequence they are not connected. The most important thing is the ratio, the 1-to-1 ratio. So sequences are functions.